Today we're working on 7.1 parallel lines. Okay, very first thing that we want to learn about parallel lines is the idea or the concept of the gradient itself. So basically the gradient, as you have learned in secondary 1 and secondary 2, is about the slope of the line. So if you have a line that is like this, then if you have a line that is slightly steeper, we know that this line has a greater gradient than the very first line because it's steeper. Just imagine a car going up a slope. So if a car is going up the slope, if it's gentle, the car doesn't quite struggle. But if the slope is actually pretty steep itself, there's a higher gradient, the car going upwards will actually have a much more difficult time in going up the slope itself. Next, the idea that we will learn today is about the angle of inclination, theta. This is the angle that the line makes with the positive direction of the x-axis. So here we have theta, and here also have theta. So the positive x direction, the graph is going this way, the x-axis is going this way. This is the angle we're looking for. The graph is going this way and this way. This is the angle that we are looking for. So basically, if you want to know, it's the angle that we're looking is facing to the right. Okay, not the one that's facing to the left. Okay, so it's the angle we're looking for. It's the one facing to the right. Now, basically is this, if you look at the previous diagram, if you remember from your secondary 1, okay, what is gradient? Gradient is rise over run. So if you just humor me, we draw a triangle. So if you want to find the gradient, it is the rise over the run. But notice this, rise over run, okay, in terms of a right angle triangle and in terms of theta, what we have here, this is the opposite and the adjacent itself. So rise over run is equals to the gradient. Okay, so the gradient is rise over run, but not forgetting as well that rise over run is also the opposite side or over the adjacent side. So if you remember from trigonometry, opposite over adjacent, what ratio is that? That's actually the tangent theta ratio. So tangent theta is equals to opposite over adjacent is equals to the rise over run is equals to the gradient itself of the graph. Hence, okay, the concept here is this: the gradient of a line M is given by M equals to tangent theta, where theta is the angle the line makes with the positive direction of the x-axis. So we're relating the gradient, okay, itself, alright, to the angle that it makes with the x-axis. Okay, so now first and foremost, let's look at example 1. So example 1 can be found in your textbook on page 158 itself. So find the acute angle that the line segment joining 1, -4 and 5, 4 makes with the positive direction of the x-axis. In this question, we have drawn the diagram for you. There is no need to draw the diagram, but this diagram has been drawn here to better help you visualize what we are talking about here. So the angle that we're trying to find with the positive direction of the x-axis, so this is the angle we're trying to find. So as we have learned from the previous slide itself, the gradient is equals to tangent theta. So what we can do is to find the gradient first. So the gradient of line segment AB is, if you recall, you need to remember this gradient M. Okay, M is a symbol that we commonly use for gradient. So it's y subscript 2 minus y subscript 1 divided by x subscript 2 minus x subscript 1. So the gradient of the line segment here is 4 minus -4. I'm using the y values, divided by x minus x2 or x subscript 2 minus x subscript 1. So what we get is 8 over 4. The gradient in this case itself is equals to 2. Then relating to what we have learned in the previous slide, tangent theta equals to 2. You inverse tangent theta, inverse tangent of 2. The theta value we get is 63.4 degrees. Don't forget that for angles, we give the final answer correct to 1 decimal place. Now, please pause the video and attempt try 1. The answer 56.3 degrees is there, and when you're ready, please unpause the video and I will give you the answer. So let the angle be theta, just like what we did in my previous slide. The gradient was 3 over 2. So I relate tangent theta to 3 over 2. And I find that the value here is 56.3 degrees. And that's the first concept. The next concept that we're going to learn is about the gradients of parallel lines. So, if they have the same slope, it's given that they will be parallel. So in this case, as you can see here, these two lines, the red line and the blue line, they are parallel. They will have the same angle with the x-axis. And also, one thing about parallel lines, the concept here that we need to know is that they will have the same gradient. So therefore, the main concept here is parallel lines will have the same gradient. Now, example 2. Determine if the lines are parallel or not. So very quickly now, I'm going to calculate the gradient of AB. So notice the notation I use here. M is a notation for gradient, subscript AB. So in this case, what I'm trying to find here is the gradient of the line AB itself. So gradient of AB, I take 1 minus 3, 0 minus negative 4. The gradient that I've calculated here will be negative half. Similarly, if I attempt to find the gradient of CD, again, note the notation, gradient of CD, I will say do minus 1, minus 0, 5, minus 3. And I find that my gradient here is also negative half. The statement I shall make is, since gradient of AB equals to gradient of CD, right? AB and CD are parallel. Okay, on to part B. So part B, my gradient of AB, I'm using this data now. So my gradient of AB in part B is minus 1, minus 0, minus 3, minus negative 4. I find that my gradient of AB here is negative 1. For part B, my gradient of CD is equals to negative 3 minus negative 4, 2 minus 1. I find that my gradient is 1. Notice that 1 gradient is negative 1. The gradient of CD is 1. Since, okay, my gradient of AB is not equals to my gradient of CD, AB is not parallel to CD. And that's it for example 2. Now, please try to, this is not a very difficult question, find the gradients and determine if they are parallel or not. Okay, for part A, what we have here is this. If we found the gradient of AB is 1, gradient of CB is negative 1. So for part A, since the two gradients are not equal, AB and CD are not parallel. For part B, if you found both of the gradients should give you negative 2, then since the two gradients are equal, AB and CD are parallel. On to example 3, collinear. What are collinear? Let me just give you an example first. If I have a straight line, I have points on them, A, B, and C. What I can say is A, B, and C are collinear. So the meaning of collinear will mean that they lie on the same straight line. So for example, let me exaggerate this. If I have a line like this, then I have another line joined like this. Okay, so it's a bit, there's a kink to it. So here is A, here is B, then C is somewhere off. Notice that A, B, and C, alright, will not be in the same straight line. They are not collinear in this case. Okay, maybe I change this A, B, C, maybe I change this to D, E, F. So in this case, D, E, and F are not collinear. Okay, collinear, there are two concepts here you can see, show that they are collinear. The first way is this: gradient of AB and gradient of AC and gradient of BC, it will be the same gradient because they are collinear. because for a straight line, the gradient will always be the same. The other way to prove that 3 points are collinear is you find the distance of AB and the distance of BC, and you find distance of AC. You will notice that the length of AC must be equal to AB plus BC. It will not work out for the second case, DEF, because DE plus EF is clearly longer than the distance. DE plus EF is clearly longer than DF itself. So in this case, they are not collinear. So do take note of the two methods. So the first method that I can use is to actually use the gradient, which is the easier method. The second method I can use is to use the distance method. Okay, now on to my example 3. So let me just erase all of this first. So now for example 3, what happens here is this: show that the points are collinear. So what I will try to attempt to find is the gradient of PQ first. So gradient of PQ will be K plus 2 minus K minus 2 divided by 2 minus negative 2. So what I will get here is on top I will get 4. On the denominator I get 4. So I get gradient of PQ is 1. If I find the gradient of QR, either you can find the gradient of QR or can find PR as well. But I will find the gradient of QR in this case. The gradient of QR is K minus 2 minus K plus 3. Don't forget the brackets there. Then we have minus 2 minus 3. So what we have in the numerator is negative 5, denominator negative 5, gradient is 1. Then since the gradient of PQ is equals to the gradient of QR, so therefore P, Q and R are collinear. That's it for example 3. Now, please attempt try 3. There are two different methods. The first method is what I presented in the earlier slide. You attempt to use the gradient, okay, and prove that the gradients, in this case, MPQ equals to MQR, alright, or MPQ equals to MPR. It will also work out. That's the first method. Second method is to find the distance of PQ and the distance of QR and try to show that is equal to the distance of PR itself. If this is true, then the 3 points are collinear. Then we will discuss which method is easier and why. In case you have forgotten how to find the distance between 2 points, which you should have learned from your elementary mathematics, the distance is given by x2 minus x1 square plus y2 minus y1 square, and you square root the entire thing. And please pause the video to try this now, and if you are ready, you can unpause the video. I give you the answers. Okay, method 1, I found the gradient of PQ to be 5 over 2, the gradient of QR to be 5 over 2. Statement is such that gradients are equal, hence the 3 points are collinear. That is the first method. So check that you have 5 over 2 and 5 over 2. Your second method itself is to find the distance between PQ and find the distance between QR and finally find the distance between PR. If you notice, in the end, PQ plus QR, alright, is equals to 3 root of 29 units. PR itself is equals to 3 root of 29, as we have proven there. Since, okay, PQ plus QR equals to PR, they are collinear. Quite obviously, method 1 is easier because the calculations are easier. And that's it.